Alright, it's time to get back after it. We have our very first geometry lesson, 1.1, titled Identifying Points, Lines, and Planes. I gotta warn you up front, this lesson is going to be pretty heavy vocabulary-wise. We're going to lay out a whole lot of terms we're going to use throughout the rest of the course. So not a lot of problems to solve, but just a lot of identifying, learning how to draw, learning how to name, and learning the definition for a lot of key vocabulary. So let's jump right into it. So the first thing that we're going to talk about is a point. And what is a point? Well, first thing is a point is an exact location. That's all it is. It's pinpointing where something is. It has no size. Now I'm going to draw a point and show you what it looks like. And so here's a point, and I understand that if I drew it like this, you'd be like, well, wait a minute. There's more size. The one on the right's a lot bigger than the one on the left. But technically, a point has no size. It's just a spot in space. All right. How we name this thing is we're going to use a capital letter. Cannot use a lowercase. We got to use a capital letter. And we'll pick whatever letter we want. I'm going to put K for craft. So there's our point. Now, when you string a bunch of points together, you end up with what's called a line. So let me draw a line first. Line should be perfectly straight. I'm kind of freehanding this, so mine's not perfectly straight, but bear with me. If you notice on the ends right here, there's two arrows, and we'll talk about that in the definition up above, what that signifies. But first thing is, a line is a straight path, no curves, and just kind of like the point, it has no thickness. Technically, a line, you can't measure the thickness. And the key feature, the hard one to kind of get, is that it extends forever in both directions. So that's what these arrows right here signify. They signify that it goes on forever. So I can't measure this line because it goes to infinity both ways. Now, how we name that is we're going to use, there's a couple different options. All right. Option number one is we're going to use 2 points. So I'm going to jump in here and I'm going to put a point right there and call that A. I'm going to put a point right here and call it B. And that's one way to name a line. So when I name it, if I want to say, hey, that's line AB, I just write AB and I put the same 2 arrows right above it. That's the notation. This right here is the notation for line AB. Now I also could call that line BA. There's really nothing that says it has to go right or left. It can go in either direction. So both of these guys are legitimate ways to name that line. Now, another feature that we use sometimes, especially when the drawings get really, they get kind of really gummed up, there's a whole bunch of other stuff going on and there's a lot of letters and it gets kind of confusing. We also might bust out a lowercase letter. And for this one, maybe I'll use L. So another way is just to refer to this as line L. So we now have basically a few different ways here to name a line. All right, our last term here for this first section is a plane. So we'll start off with a definition and then we'll draw it. So a plane is basically a flat surface. You can think of it as like a desktop or a wall or a mirror or a sheet of glass. It has no thickness. So this plane has no thickness. And similar to a line, it extends forever in all directions. And I'm going to go ahead and draw this. Typically in math, we draw a plane kind of like a parallelogram. And it just kind of looks like a sheet of paper or something. But realize these go forever in all directions. This thing really just keeps on going and going, and there's no end to it. It's like an infinite sheet of glass. But when I'm drawing it on paper, I got to stop somewhere. So we normally put it as a parallelogram. Now, how do I name this? I can name it a few different ways. One way is I can name it using 3 points that live on the plane. So I'm going to just put a couple points in here. I'm going to put point C. I'm going to put point D. I'm going to put point H. And there's basically a plane with 3 points on it. And when I want to name it, so how I name it is, I'm just going to call it plane CD H. And really the order of the letters is not important. I could have did HCD or DCH, however I want to. And kind of similar to a line, sometimes they make life easy for us and they just put a little uppercase letter somewhere in one of the corners. It could be in any of the four corners, any of these, but another way to name it would just be to call it plane P. Alright, so those are our first three terms, point, line, and plane. And we're going to kind of use this to build on and create a lot more geometric figures and shapes as we go out through the course. Alright, so moving on down through the notes, collinear points. Collinear points are special points. They're points that lie on the same line. Alright, so you kind of get this linear part means line, and this co part here breaks down and refers to the same. So collinear, same line. So I'm going to just draw an example of that. I'm going to draw a line here, and collinear points, I'm just going to put a few on here. Let's put on Q, R, and S. And so I would say that Q, R, and S are collinear. And then if I have a point somewhere else, like maybe this point T is just chilling up in here space somewhere, point T is not collinear. Okay, or non-collinear. So I'm going to put non, meaning not collinear. And the same idea extends over here into planes. Let me go ahead and draw a plane for us. You'll want to do this in your notes as well. So I have my plane, and I'm going to put some points on there. Just trying to use some different things and mix it up a little bit. F, G, and H. These points would be coplanar. Again, same plane. They live on the same plane, the same flat surface. And then there might be some other point chilling somewhere. You know, maybe I'll just throw it J. And J is below the plane. Okay, or maybe it's above the plane. But when it's outside of the parallelogram there, it shows that it's not living in the same plane. And we would say that it's non-coplanar. So J is non-coplanar. Alright, so let's jump into an example and see if we can kind of put some of these ideas into practice here. So example 1, part A, give two other names for line B. Well, first of all, I come over here to my diagram and I'm looking around. I'm like, alright, there's B. So B is representing this red line right here. B is representing that red line. And so I need to look and see what points are on the line. And when I look at it, my points L, M, and N are all living on that line. So remember, another way to name a line was pick any 2 points. So I could choose LM. Got to put the right notation above it. That's super important. I could also use MN. I could use LN. And then I could also reverse the letters from all of these. So I could actually have 3 more. So there'd be 6 different ways to name that line. Now, give another name for plane Z. So they named it as a capital letter in the corner, which we talked about earlier. That was okay. And now another way to name it is to pick any 3 points. Now, there was one little tiny thing I left out. When you're going to use 3 points on a plane, you have to make sure that they do not lie on the same line. So I'm just going to put here in parentheses, another way to do this is 3 non-collinear points. Alright, so an example I could not use, I could not call this plane LMN. And I'm going to show you in class with a different drawing why, but you would not want to name it that way. I have to have non-collinear points. So let's just pick maybe point L, point P, and point N. Those are 3 points that live on the plane but do not live in the same line. So here's one way to name the plane. Here's another way to name the plane. Just remember, you can use a capital letter in the corner or 3 non-collinear points. Alright, name 3 points that are collinear. Well, remember up above, collinear meant they lived on the same line. So I think my choices here are going to be L, M, and N. These 3 points right there. And I'm going to separate them by commas because I'm showing you that these are 3 distinct points right here. as opposed to smashing them all together like I did over here, which represents a plane. So the commas are kind of important. Okay, so I'm going to start with part D now. Name 4 points that are coplanar. I got to name 4 points that live in the same plane. Well, there's really only one correct answer, and that is points L, M, N, and P. Those are the 4 points that live on the plane. Now, one thing that I want to kind of highlight here that people kind of screw up on, and just kind of an error alert, I call it, is this is not a point. That's a letter that names the plane. This is not a point either. B actually is another name for the line. So you can see who the actual points are. They're L, M, N, and P. So be careful on that. Last one, part E. Name a point that is not coplanar with L, N, and P. So L, N, and P are all right here. Who is a point that is not living in the same plane? Well, the answer to that one is going to be point Q. Point Q is chilling up there up above. So point Q is a point that is not coplanar or non-coplanar. Moving right along, we get down to some new terms here. A line segment. So we'll start the definition, and I went ahead and typed it out for you so we didn't have to write all these words. But a line segment is basically a part of a line that consists of 2 points called endpoints. So let's go ahead and draw those first. 2 points. We'll call them L and K. All right. There are 2 points called endpoints, and all the points on the line that are in between. So notice it doesn't have the arrows on the end. It's just a piece or a chunk of the line. And we actually can measure the length of a line segment, which we're going to be doing in the next couple sections. So a segment actually stops at 2 different places. So that's pretty important. There's 2 ways to name it. You always name it using the endpoints. So if I wanted to refer to this and I wanted to say, hey, draw segment LK, or if I was getting lazy and I didn't want to write all that out, I just write LK and then I put a straight line up above it. Okay? Or you can always reverse the letters. But the key feature here is that I have a straight line up above there and there are no arrows. That's what denotes the difference between a segment and a line. Alright, a ray is kind of like a hybrid between a line and a line segment. It's got kind of key features from both of them. So it's a part of a line that consists of a point called an endpoint. So let's go ahead and just put an endpoint on here. We'll put C. There's one endpoint. And then all the other parts of the line extend forever in the other direction. So it starts off with one endpoint, it shoots out in the other, kind of like a laser beam almost. And I'll put another point on here, call it D. So if I want to name this, or if I wanted to use proper notation, there's really only one way to write this. It's CD, and then up above, I'm going to kind of put like an arrow. All right, and there's a couple tough pieces of this. One thing, this arrow up here must always go to the right when you're naming it. Now the picture, the arrow can go any direction, but when you actually name it and you actually write the notation, the arrow has to go to the right here. And it's always got to be written in a specific way. This first letter right here has to be the end point. I'll just kind of put ENDPT for short. And then the second letter that's below the arrow is the point that it goes through. So it would be incorrect on a quiz or on a test if I said, hey, name this figure here. If you called it DC, that would be wrong. All right, that's not allowed, because D is not the end point and C is not the point that it goes through forever. Now, some kids want to try to write it like this. They want to try to write, maybe D, C, and go that way. And while kind of technically you're right, at least C is on the endpoint side and D is on the other side, it's just kind of not a standard way that mathematicians do it. We really never write this arrow going to the left when we talk about array. Moving to the next segment of notes, we have a special pair of rays called opposite rays. And opposite rays are basically 2 rays that share the same endpoint, and they have to form a straight line. So there's kind of 2 key components here. Share the same endpoint, that's the first feature, The second feature is you must form a straight line. So let me draw an example of opposite rays and then some things that are not opposite rays. So a pair of opposite rays would be, maybe I'll draw this one and I'll call it AB. So there's ray AB. And another ray that shares the same endpoint and forms a straight line would be ray AC. So if I asked you to draw this on a quiz, this would be a great drawing of opposite rays. And if I had to name them, I would say ray AB and ray AC. Notice the A's line up over there on the left-hand side because they share the same endpoint. So I can visually look at it really quick and say, hey, these guys share the same endpoint. They both start at A. Now, some things where people sometimes get confused are, this would not be an example of opposite rays. Let's just call this X and we'll call this Y. And then maybe I'll come down here and I'll call that Z. I kind of do something funky with my Z's. You know, most people draw a Z like this. Sometimes when I'm going fast, it kind of looks like a 2. It gets sloppy. So whenever I draw a Z, I always put a little slash through the center. So that's what my Z's are going to look like. But this picture wouldn't work because this is a violation of part 2. It does not form a straight line. This forms an angle that we're going to learn about later, but it doesn't form a straight line. So sometimes people think that these are opposite rays, but they're really not. Alright, so the next word we're going to look at is intersection. An intersection is basically like the overlap, or what two objects, the points that they share. So maybe I'll draw an example of a circle, and then maybe I'll draw a triangle. And if I said, hey, where is the intersection of these two shapes? They're the points that they share or have in common. So this point right here and this point right here, and we could name them. Maybe I'll call it point K and point R. K and R would be referred to as the intersection points. Let's move on down and let's check out example 2. See if we can put this into practice. I'll go a little quicker through this spot. Alright, so part A, looks like we have 2 lines over here. I know they're lines because they have these arrows on the ends. So we have 2 lines. Give another name for segment VX. Well, segment VX is this section, this part of the line right here. That's segment VX. The only other way to name it would be to reverse the letters and call it XV. Again, be very sure that you put the correct notation up above. Alright, part B. Name all rays. All rays. So we got to do all of them. Name all rays with an endpoint of W. Well, and there's no point drawn here, but we know that they intersect right there, so I can kind of draw my own point. But all rays that end with an endpoint of W, well, I think there's 4 of them. There's that one, WX. Notice my W's first because I have to put my endpoint first. There's WZ. There is WY. And finally, WV. And I probably should put commas in here to break them up and show you that I actually named all 4 of them. I don't think there's any other rays that have an endpoint of W. Alright, so part C. Get rid of this here. Which rays in part B are opposite rays? Well, there's a couple different sets. Remember, the key part of opposite rays are they have to form a straight line. So one pair I think would be WX, and then going in the exact opposite direction, WV. So there's a pair that are definitely opposite rays. Now a different pair would be if you wanted to pick the other 2 going in the other directions. WY and WZ. So this would be another acceptable answer. So on the quiz or on a test, I'd have to accept both answers because they're both correct. Alright, part D. Give another name of the line. Give another name for line, and how I know it's a line is because I'm looking at this up above and it's got the arrows. So give another name for line YW. Well, line YW isn't just this little piece right here, but it's a line, so it goes forever. So that's line YW, and there's several different ways to use this. You can pick any 2 points that live on that line. So I could simply just reverse the letters if I wanted to kind of find the easy way. Or if I wanted to think a little bit more, I could use the other 2 letters. I could use W and Z. I could use Y and Z. And I could flip letters around. There's a lot of options. I'm not going to do all of them, but there are more choices too. Alright, so let's take a look at part E. Are Vx, and the notation up above says, are ray Vx and ray XV the same ray? And then I have to explain. Well, let's just kind of go over and highlight the diagram. Ray Vx means I start at V. Remember, this is the end point. So I start at V, and then I go forever through X. So there's ray Vx. And then when I look at the second one, ray XV, the end point is X, and it goes in a completely opposite direction forever. So these are not the same ray. And how I explain this is I'd say they do not have the same endpoint. Do not have the same endpoint. So they are not opposite rays. Alright, let's move down to part F. We're getting closer to wrapping these notes up. Are XV and VX the same ray? Explain. Well, they're trying to trip us up a little bit here. Technically they are, because when I look at my notation, V is the endpoint and it goes forever through X. And over here, V is the endpoint and it goes forever through X. So yes, they're the same ray, but it's kind of like in English what you would say is bad grammar. You're not going to meet many mathematicians or math teachers or students that are going to ever draw a ray looking like this. So a little bit of a trick question. Alright, let's move on down to the final example. And these go kind of quick because these are just true or false. So we'll bust this out and have our first lesson in the books. So number 1, so notice over here, this is the picture of 2 planes intersecting each other. So just kind of overall what's happening, I'm going to write this off to the side. This is 2 planes that intersect each other. And remind me tomorrow in class to show you guys a picture of this using paper or cardboard. It might be a little bit easier to see. But I have the shaded plane that J, K, and G live on. And then I have the white plane that E, G, and F live on. So 2 totally different planes. And let's go ahead and answer some questions. Are points H, I, and G collinear? So H, I, and G, do they all live on the same line? Yes, they do. They live completely on a perfectly straight line. Now you might be like, well, hey, HI is a segment. But it's really not a segment, because remember, these planes here go forever in all directions. It's just when we draw it, it has to stop somewhere. So this would be true. Looking at the second one here, are points HI and J coplanar? Points HI and J. So let me get rid of my line here and let's just focus on number 2. H, I, and J. Do they live in the same plane? Yes, they do. They actually live in the gray plane, the shaded plane. So that is true. Number 3. EG and FG are opposite rays. Well, I'm going to tell you just by looking at these, to be opposite rays, you have to have the same endpoint. This ray has an endpoint of E, this one has an endpoint of F, so I know right now it's false. Those 2 cannot be opposite rays. And if I draw it, EG is this ray going forever, and FG, I'll do this one in red, FG goes this way forever. They're kind of like opposite rays because they do form a straight line, but the key thing is not the same endpoint. That's a critical feature. It has to have both pieces. Same endpoint and form a straight line. Alright, number 4. All points on ray, and again I know it's a ray, this is really important here. All points on ray GI, so let's talk about where that joker is. He's right here. Ray GI are all the points on GI and all the points on GF coplanar? Do they all live on the same plane? This one's a little bit tricky to visualize, but if you can imagine this white plane right here, if it was a sheet of glass that went forever in all directions, I think both of these lines would keep living on that white plane if it were to extend out and get bigger and bigger and bigger. So this one is true. And when you get into 3D space, it gets a little bit tricky sometimes. All right, number 5. The intersection. Remember, intersection is the common points, or the points they share. The intersection of line EF and plane JKH. So JKH is the shaded plane here. What is the intersection point or points of that line and that plane? Well, I'm going to kind of draw it a little bit differently. I'm going to come over here to the side, and this is the shaded plane. That's plane JKH. And I'm going to draw EF coming through and intersecting. So it comes through. I like to kind of put hidden lines when it's like behind it. Boom, it pops through, and then it comes out the other side. It's almost like an arrow going through a piece of paper. And right here is the intersection point. So they say the intersection of EF and plane JKH is line HI, and I disagree. The only point that the purple line there, EF, and the plane share is this point, point G. So this is false. This should read point G if you were going to make it correct. All right, moving on down to number 6. Number 6 says the intersection of 3 lines, EF, HI, and JG. EF, HI, and JG. Where do they all intersect? Do they intersect at point G? And I believe they do. That is the one point that all 3 lines share. So this one is true. Definitely true. Number 7. Moving on down to number 7, the intersection of plane EGH. So EGH is the white plane there. EGH, we got E, G, and H over here chilling on the side. That's the white plane, so we're talking about the horizontal plane. The intersection of the horizontal plane and then GJI is the vertical plane, is the intersection of those 2 planes, point G. And this is false. And I think number 8 kind of explains what is true. Number 8 says the intersections of plane EFI, which is, again, this is the horizontal plane or the white plane, and JKG is the vertical plane or the shaded plane. Those 2, the points that they share in common, are actually right here. Those are the points that both planes share. So this one would be true, and the one up above would be false. Alright, so not too bad. A little bit longer maybe than some of our other notes, and a little bit dry because there's a lot of vocabulary. But tomorrow when you come into class, we'll get down on the practice sheet and get to work.